Hello, I'm Richard Young, your host with Facundo Batista and Kaylin Overholt for MIT's course on COVID-19, SARS-CoV-2, and the pandemic. The purpose of this course is to learn what we know today about COVID-19 from the world's top scientists. And today I have the pleasure of introducing you to one of the world's most talented epidemiologists, Professor Salim Abdool-Karim. Professor Karim is a South African clinical infectious diseases epidemiologist widely recognized for his scientific contributions and leadership in AIDS and COVID-19. He's the director of the Center for the AIDS Program of Research in South Africa, Durban, and professor of global health at Columbia University in New York. He's also adjunct professor of immunology and infectious diseases at Harvard University, adjunct professor of medicine at Cornell, and pro-vice chancellor of research at the University of KwaZulu-Natal. Professor Karim is a member of the African Task Force for Coronavirus and a commissioner on both the African Union Commission on COVID-19 and the Lancet Commission on COVID-19. He's a member of the WHO TB-HIV Task Force and the Science Council of the World Health Organization. Professor Karim is also a member of the U.S. National Academy of Medicine and the American Academy of Microbiology. He serves on the boards of the New England Journal of Medicine, Lancet Global Health, and Lancet HIV, and he's a fellow of the Royal Society. Professor Karim, thank you for talking to our students and viewers about COVID-19, looking ahead at 2022.
It's a great pleasure. Thank you very much, Richard. It's an honor to be here. And I hope that over the next 40 minutes, the information I share, the perspectives I share will be of interest and will give you some idea of COVID-19. Looking back as a way of understanding where we're coming from, in order to look ahead. So that's what I would like to share with you. And what I want to do is, I'll just briefly touch on the pandemic at a glance, but I will focus on three things as I look back. I will look back at the three most important new technological developments in COVID-19. I will look back into what I consider to be three of the critically important mistakes that we made in the COVID-19 response. And I will look back at three of the most underestimated challenges in COVID-19 and before I focus on looking ahead. So that's what's in store for you. So let's start with looking back. Let's start with getting a sort of perspective of where we are. And most of you are familiar with this, that we have had a coronavirus pandemic that has impacted the world in the form of wave upon wave of infections. And these waves are also associated to some extent with variants. And if you look at where we are right now, almost a 250 million new cases that we have had in the course of this epidemic, or this pandemic, and almost 5 million deaths. But this is more than just a viral infection. It has had major global impacts. If you take the World Bank report, the most recent, focused on the number of people who are extremely poor and how the pandemic has impacted on that, it's shocking to learn that there's as a consequence of this pandemic, there are an extra 150 million people that are now extremely poor. That the World Food Program has identified that there are 161 million more people who are now food insecure and who go hungry each day. And this pandemic has created other epidemics, and most particularly what is referred to by WHO as the infodemic, where we have all kinds of conspiracy theories and uncurated knowledge and information, largely misinformation, being spread largely through social media. But this pandemic has also created political instability. It has led to protests against COVID-19 restrictions. And, you know, election after election, we are seeing how success in dealing with the pandemic is important to achieve re-election. And we've seen how that political instability and protests have translated themselves into the public that's concerned that the pandemic is being used as a way of introducing authoritarian measures. Many instances unwarranted, but certainly one where we are seeing an increased level of polarization within our society, driven not only by organizations like social media like Facebook, which does so deliberately, but the pandemic is also polarizing people in relation to their whether they accept that these restrictions and public health measures are warranted or just an encroachment of government. But for me, one of the worst things we have seen in the course of this pandemic among the 5 major global impacts is the way that this pandemic has shone a sharp light on disparities in our society. Disparities of race, of gender, disparities in data access, and now even vaccine access. So let's go to looking back at 3 of the most important new technological developments. And let me start with vaccines, which is the obvious one. When we think back to the first report of the announcement of cases that was made of unknown pneumonia, it came to most of us in the world through a ProMed alert. I remember I was on vacation, hiking in the mountains, and my iWatch gave me a little ProMed alert that there's, you know, unknown pneumonia cases in Wuhan. And that was on the 30th of December, 2019. And when you think that within a matter of 11 days, the first genetic sequence of the novel coronavirus was already made available. And in fact, it was first made available through Twitter. I said, this is, you know, setting a new benchmark for me about how we convey scientific information. Normally, you know, a sequence like that would have been peer-reviewed and appeared in Nature or something like that. You know, now it's available on Twitter within 11 days. And of course, within a month, the World Health Organization declared SARS-CoV-2 a public health emergency of international concern. In fact, it wasn't called SARS-CoV-2 at that time. It acquired the name a little later. So when you go back to a situation where we only knew the sequence of the virus on the 11th of January, and here we are, you know, not even 9 months later, on the 9th of November, you have Pfizer and BioNTech releasing the first results of a successful vaccine against SARS-CoV-2, a trial that was undertaken in the US, Turkey, Germany, South Africa, Brazil, Argentina, truly international effort to try and get this trial done as quickly as possible to produce a result. And since then, we've got a whole panoply of different vaccines that have been shown to be efficacious and are now in widespread use. But we've also seen amazing innovations in diagnostics. I mean, from the time we had the sequence, it was not even 2 weeks later that Christian had released the first PCR assays for SARS-CoV-2. And now we go beyond PCRs into rapid antigen tests, which are widely available. In fact, I'm just coming from a week at the Pasteur Institute in Paris, and virtually everywhere you go in Paris, they offer you a rapid test. They have tents that they just, you know, you can just have a test whenever you want. And you go into a pharmacy, you can buy a rapid test, take it home and do it. So we have, within a matter of such a short time, and I think back, you know, it took us 4.5 years in HIV before we had a rapid test. So, and that's a much easier test because that's an antibody test. So what we have seen is nothing short of revolutionary in terms of the speed with which we've produced highly accurate diagnostic tests. And for that matter, I mean, highly efficacious vaccines as well. And of course, the work continues to generate innovations in therapeutics. We've seen the amazing initial results from the recovery trial of dexamethasone, and since then, we've seen several important new results, whether it's tocilizumab, tocilizumab, or whether it's the combination of antibodies, or whether it's the newest result that we've seen from Merck of the tablet of molnupiravir. All of these are providing us with ammunition. And this is about science triumphing or being triumphant over the challenges that this virus brings to us. But in the realm of treatment, it's not only important to produce data and results on treatments that work. It's also just as important to do trials and show that treatments don't work. And we've seen how drugs like azithromycin, hydroxychloroquine, favipiravir, ivermectin, convalescent plasma, Kaletra, which is lopinavir boosted with ritonavir, that all of these have now gone into the dustbin because they've been shown quite conclusively to provide no clinical benefit. So we are cutting through the misinformation. We're providing a set of therapeutic options that will enable us to make a dent on the mortality rates from SARS-CoV-2. So let's go back to looking back now at 3 critically important mistakes, at least from my perspective. So we've touched on 3 major technological developments in vaccines, therapeutics, and in diagnostics. Now let's look at the response itself. The first was a major debate, and I was one of those unfortunate enough to get caught up in this debate when a group of scientists came together to produce what is called the Barrington Declaration, the Great Barrington Declaration, named after the little town where they held their meeting. And it was such an important declaration because it provided a perspective on this pandemic that was looking for a formal home. And these scientists came together to provide it with that formal home, which was to say, just let the virus spread. We don't want lockdowns. We want just everybody to just get infected. We protect the vulnerable, the elderly, and we see that as a better alternative to the lockdown. Well, I would have none of that because the logic at that time was nonsense and it remains nonsense. And now in hindsight, we have a very clear understanding that this was really seriously ill-advised. And being among those that challenged the Great Barrington Declaration, it's now, of course, water under the bridge that it was a bad approach to dealing with this pandemic. And there are several errors in it. The first is, of course, that as the new variants emerge, they have a higher reproductive rate of infection, which means the level of immunity you need within the community rises quite rapidly, especially when you take the Delta variant that has an R0 that's close to 5, which means that you have to have more than 80% vaccine coverage in order to achieve herd immunity. And of course, we now know that if we had to let this virus infect 70–80% of the populations, the deaths would be amazing and just unacceptable. And so we know that letting the virus just spread naturally would be enormously harmful and would simply not lead to herd immunity. And that it's very difficult to protect the vulnerable because most elderly people live with others who either in multi-generational households or have carers who get infected and lead to the virus spreading. But it's not only about dying. We also have to worry about long COVID. And so this idea that we'd allow 70%, 80% of the population just to get naturally infected. And of course, now we know that natural antibodies wane quite quickly, and there are high levels of reinfection. We saw that in South Africa, where infection in our second wave with the Beta variant provided almost no protection against reinfection with the Delta variant. So we're seeing that natural immunity doesn't really provide the kinds of cross-immunity as new variants emerge, because these new variants break through immunity, at least partially, from past infection to cause new infection. So the promise of herd immunity from natural infection simply was inappropriate and was shown to actually be a bad policy approach. And many countries, not many, there were a few that chose this path, Sweden being one of them, learned the lesson very quickly and switched to alternative approaches to suppress viral transmission. The second was that we spent the first, almost 10, 11 months of this pandemic looking at the virus. And in South Africa, I chaired our country's ministerial advisory committee as its chief COVID scientist. And every month, my colleagues who do the phylogenetics, who do the genetic screening, would come and present the data to me. And every month, there would be one or two minor changes and emerging alternative, variants. And they were really nothing to write home much about. In fact, when it came to September, I said, do we still need to meet? But we said, let's just meet anyway and just have a cup of tea. Well, in November, all of that changed when we discovered in South Africa the beta variant. And we were actually lulled into a bit of complacency because of the genetic stability of this virus. From the ancestral strain, there was just one mutation at D614G that became the worldwide dominant form of the virus. But now we know, because we've had reports from the UK about the Alpha variant, we reported from South Africa the Beta variant, our colleagues from Brazil, the Gamma variant, and in India, they reported about the double mutant, which we subsequently learned was labeled, well, the WHO labeled it the Delta variant. And we're not sure now what's the next variant, because we have several variants of interest, but only 4 variants of concern. And we're not sure what the next variant of concern is going to be. And if there is even going to be another variant of concern, because we now have a better understanding that we have to be ready to deal with these variants. And if you look at the impact of variants in the pandemic, and here I'm showing you the first wave in India, in Brazil, and in South Africa. And you can see that, India actually, they had such a mild first wave, the politicians declared that they had conquered this virus. And that's what led to easing a lot of restrictions in India. And Brazil, of course, has had a terrible time of the pandemic, largely because of very poor political decision-making, much like the US in its initial stages of the pandemic. And South Africa, we had a very neat, clean first wave that rushed through, and we were over with it pretty quickly, largely through suppressive mitigation steps. And in all of these 3 countries, the variants led to quite dramatic subsequent waves. In India, we saw on our television screens the heart-wrenching, videos and pictures of how people were dying in the car parks, just can't get into hospitals, not enough oxygen available. We saw how in Brazil, the Gamma variant spread rapidly and pushed the epidemic in Brazil to highs that really were quite shocking. And we saw how in South Africa, the Beta variant led to our second wave, and the Delta variant led to our third wave. And we know that these variants have changed the endgame, because now we have to seriously look at each of these variants. And we have to be seriously concerned about whether new and emerging variants of concern, whether they may or may not be able to escape some of the vaccine immunity. Whether that happens is left to be seen, but it's become critically important to understand variants, because they are going to determine whether we can simply look at high vaccination coverage with our current vaccines in the hope that we can go back to some sense of normality. The third thing I think that we've made a very serious mistake on is that we've promoted self-interest at the expense of the pandemic, at the expense of the pandemic response. And that's what led to the vaccine inequity that we are seeing. And that we can see here that while at a global level, about 50% of the entire world has been vaccinated, about 6.5 billion people, in Africa, less than 5% of people have been vaccinated. That is scandalous, especially when you take that, Johnson & Johnson had commissioned a company in South Africa to fill and finish their vaccines. And that South Africa, which couldn't get hold of vaccine doses for months, was producing these vaccines, and 32 million doses were produced in South Africa, and every one of those 32 million doses was shipped to Europe, none to Africa, just highlighting the gross challenges in inequities that we seriously were blundering on. And this problem has become, in many ways, the defining aspect of this pandemic at this time. Because when you think about the first results from Pfizer and BioNTech, to the point where about a month later, the first person in the world was vaccinated outside of a clinical trial, given an AstraZeneca vaccine in the UK, and you look at availability of vaccines, essentially the countries that developed vaccines got vaccines first. So that's the UK, the US, Germany, India, China, Russia. Now they developed their own vaccines and they had access to those vaccines immediately. And the US, of course, spent billions of dollars in Operation Warp Speed to do that. So they were the first to get vaccines. The second group of countries to get vaccines were those that were able to secure advanced market commitments. So these are wealthy countries that went to companies that were making vaccines and said, we want to buy your vaccines, even before we know whether it works or not. So you had a situation where a country like Canada was bought over 9 doses for every one of its citizens. And the reason? Very simple. They were not taking any chances. They were buying vaccines from everybody. Right? Because they don't know which one is going to work. So they were just not going to take any chances and just get every vaccine. So countries like Israel, Denmark, Canada, Australia, they secured vaccines through advanced market commitments. But poor countries can't do that. They don't have the cash to make that kind of deposits, which were around 50% of the cost of the vaccines at the time, because the drug companies were using that advanced market commitment to start scaling up manufacturing at risk, so that when the vaccines are shown to work, they can be rapidly scaled up. And then you had a situation where the next group of countries secured vaccinations. From around late February, March, these countries started getting vaccines. The United Arab Emirates, Turkey, Egypt, Morocco, Chile, and they secured vaccines through what is referred to as vaccine diplomacy, which is just a euphemism for countries that had vaccines donating vaccines to others for political maneuvering, to get some quid pro quo. And Russia and China started it, the US and the UK followed later by making huge amounts of donations. And of course, you only donate to the people you want to donate to, and only because you're trying to get something in return. And then you got those countries that made bilateral purchasing agreements. South Africa is one of those. So we simply entered the marketplace. There were a whole lot of companies now selling vaccines. We bought them at the going price, often paying more than other countries because we're not that good customers, so we're not given favored time schedules for our vaccine supply. And then the one mechanism that the world created, the WHO, CEPI, and Gavi created to distribute vaccines equitably was called COVAX. COVAX was last to get vaccines. So the one mechanism for equity was the one to get vaccines last. And so these 5 disjointed, separate ways of securing vaccines was a huge mistake. It was a mistake we chose, but a mistake that is really showing us what it is to have a broken vaccine distribution system. So just how broken is it? Well, instead of being a global public good, because you need a vaccine to control a pandemic, it has to be distributed every corner of the globe. But instead of treating it like a global public good, we treated it like a commodity to buy and sell. We treated it as something that could be used for political benefit, and that led to the creation of vaccine inequity. In my view, nothing short of vaccine apartheid, and we know that the UN called apartheid a crime against humanity. And one must understand that there's really an urgent need to create some kind of equitable vaccine distributions and some kind of vaccine equity, because there are dire shortages in the midst of glut. And I mean, we've seen this with food, we've seen this with other things, we're seeing it with COVID-19 vaccines. That you've got countries like the US, where they are literally hoarding vaccines, and so you have millions of doses expiring, wasted, whereas COVAX can't even get enough vaccines to meet its 2021 delivery targets. There's a shortfall of 470 million vaccine doses in Africa just for this year. So I hope I've given you a sense of how serious this mistake was. So let's go on to looking back at the 3 most underestimated challenges in COVID-19. So the first that I just simply didn't see this coming. We understood that this was an acute infection. People either recovered or they went to hospital, they got sick, were on oxygen, and they either recovered or they died. But it took a while, and then we began to see the cases emerging of people with a chronic form of this condition. In fact, we still don't fully understand it. And it was given the original name. I remember those first papers that came out, they were called long haulers, just people who were just not recovering, and 3 months after their infection still had symptoms. Many of them still had no taste, couldn't smell, and the commonest symptom is just this brain fog. That's the way they describe it. And my patients talk to me about, they just can't concentrate. They can't read, they can't do, they're just not functional. They're feeling tired all day, they're feeling out of sorts. And it's more common than we think. And, we're just coming to grapple with this problem and to find some kind of definition for long COVID to start with, let alone try to understand its pathogenesis and its potential treatment. The second is we deeply, underestimated how medical doctors would be complicit in anti-vax information and to promote unproven COVID-19 treatments. And you've had it just as bad in the US as we've had it in South Africa. No, maybe I speak a lie. I think it was worse in the US than it was here. But we had, for example, South Africa's first women heart surgeon went on this huge tirade of anti-vax sentiments, discouraging people from taking vaccines. On the right-hand side, this is on our national television. This doctor who normally runs a slimming clinic went on this huge tirade and took our government to court to make ivermectin available. And eventually, the courts ruled in their favor that ivermectin should be made available, regardless of whether it's known to provide any benefit. And in the US, you've had doctors like Dr. Emanuel, who promoted hydroxychloroquine, was a big favorite of your past president. And then you had Dr. Pierre Kory, who in Senate, just spoke lie after lie. Ivermectin is 100% cure and all kinds of things. And these kinds of fringe doctors promoted ivermectin. In fact, I can't quite understand why so many of the medical people who are anti-vax are so pro-ivermectin. It doesn't make sense to me, but it's true. Most of the anti-vax doctors in South Africa are very strong ivermectin supporters, even though there's no evidence to show that it works. The third thing we underestimated was the complexity of understanding vaccine efficacy in relation to a whole lot of other things, including variants. And so here I'm showing you, we did 4 vaccine trials in South Africa. And what we saw is that when you take the AstraZeneca vaccine, that while it was 70% efficacious in the UK, it was 10% efficacious only in South Africa against the beta variant. Even the Novavax vaccine, which was 89% effective in the UK and was actually over 90% effective in the US, was only 43% effective in South Africa in the midst of the beta variant. We even saw that there were reductions in efficacy from the Delta variant. But fortunately, in South Africa, we saw how the Johnson & Johnson vaccine maintained its efficacy at 72% in the US and 64% in South Africa. And Pfizer vaccine, the original trial, remember, included South Africa, has remained 100% effective. It was a small study. It was about 800 participants in the Pfizer trial in South Africa. But nobody in the active arm has become infected. We've had about 9 infections in the control arm. But even with Pfizer, we saw a reduction in vaccine efficacy against the Delta variant. So different vaccines have different levels of efficacy against the different variants. And the variants impact vaccine efficacy in very different ways. Fortunately, the mRNA vaccine seemed to be holding up quite well against the different variants. But that's not necessarily true of the other platform technologies for vaccines, like protein subunits or viral vectors. Second is that what we have been seeing is, because we're dealing with very short-term clinical trials, we don't know about the long-term immunity of these vaccines. And so there's a lot of discussion right now about whether immunity is waning. And I've just presented to you here some of the data that has been used. So if you look at the original Pfizer phase 3 trial, at their 6 months of follow-up, efficacy was 95% shortly after the trial, after the last doses were given, mean of around 2 months of follow-up post-second dose, it was 95% efficacious. At 6 months, the Pfizer vaccine, the 2 doses, was still pretty good at 91% efficacy. However, when we look at some of the real-world experiences with the Pfizer vaccine, if you look at Qatar, that vaccine efficacy dropped from 82% in month 1 to 12% at month 5. And asymptomatic infection efficacy dropped from 73% to 24% at 5 months. And one of the papers you might have seen last week in the Lancet showed that if you analyze the Kaiser Permanente data, you see that in California, the vaccine efficacy, and this is 2 doses of Pfizer, goes down from 88% in month 1 to 47% in month 5. So what we are seeing is a decline in the real world experiences in immunity and vaccine efficacy up, out to 6 months with the Pfizer vaccine. And if you look at the figure on the right-hand side, this is the data that was used by Israel in their decision to give booster doses. So this is the Goldberg data. And if you look at for any clinical symptomatic COVID-19, you can see that individuals, regardless of age, who were vaccinated in January, that's the first blue bar, or February, where you're looking at the red and green bars, you can see that their vaccine efficacy was substantially lower than those who've been vaccinated more recently in Israel's July wave 3. So what we are seeing is that across the board, even though it wasn't seen in the actual original phase 3 trial, that in the real world experience, that vaccine efficacy is going down. Now, initially, we all thought, well, it's a Delta variant problem. Well, the Kaiser Permanente actually analyzes the data by Alpha variant and Delta variant, and they find that vaccine efficacy is going down similarly against the Alpha variant as it is for the Delta variant. So it seems not just to be a Delta variant problem, although it seems Delta variant is compounding this problem of waning immunity. And should be pointed out that, I mean, there's no vaccine that you give and it always maintains the same level of immunity. I mean, when you take SARS-CoV-2 natural infection, immunity wanes quite fast after the first 2 to 3 months. So in vaccination, we would expect something similar. And we know that with SARS-CoV-2, the half-life is around 60 days. So when you take 6 months later, that's almost a log lower in the antibody levels. And so we're likely to see more symptomatic clinical infections, and in this case, also asymptomatic infections. But when we look at whether immunity is waning against severe COVID-19 and hospitalization at 9 months, the answer to that is no, it's not. In fact, these vaccines hold up quite well at 6 months, well over 90%. Study after study after study shows that against the vaccine efficacy for severe disease or hospitalization is pretty high. And of course, we understand that severe disease is influenced quite substantially by T cells and not just by antibodies. So we're seeing the benefits of T cell immunity in maintaining lower levels of maintaining consistently high vaccine efficacy for severe disease and hospitalization. And if you look at the Goldberg data on the right-hand side, in these data for the 60 plus, you can see that vaccine efficacy for severe disease and hospitalization drops from 91% to 86% for those who are vaccinated in January. But that difference is not, strictly just a vaccine waning immunity problem, because in Israel, those who were vaccinated in January were largely the older people. And the vaccines, and you would expect that the older people will have lower levels of efficacy anyway, because their T cell responses are lower. But even at 91% or even at 86%, I mean, that's pretty high efficacy. I think we are somewhat spoiled with these high efficacy vaccines in COVID-19. In the world of vaccines prior to this, we were used to vaccines that don't work all that well. I mean, even poliovirus vaccine, which has eliminated polio, hasn't been anywhere near this kind of level of efficacy. The only vaccines we have that are this good, are measles vaccine and HPV vaccine. If you take some of our other vaccines, they're nowhere near in this sort of range. So this is pretty good coverage. So there's certainly no good evidence that there's waning immunity for severe disease and hospitalization, though there is waning immunity that we are seeing for clinical infection. There's a clear case, I guess, to be made for immunocompromised patients and for the elderly. I've already highlighted that for the elderly, they have lower immune responses, antibody levels as well. And so giving them boosters is not a bad idea for that reason. And so there's a case to be made for making boosters available to immunocompromised patients and the elderly. And it's important because in countries like the US, they are hoarding vaccines in order to give booster doses. And in the US, the policy decision is to give elderly and the immunocompromised individuals. But when wealthy countries start giving booster doses to the entire population of adults, then basically in Africa and in the poor countries of this world will never get vaccines. Because, I mean, you take when Israel made its decision to provide booster doses to its entire population, they secured the doses that they needed from Pfizer well ahead of COVAX, which had submitted and bought vaccines from Pfizer before that. Even South Africa, which had bought 20 million doses of Pfizer vaccine, couldn't get its doses for months on end because vaccines were being sent to the wealthier countries who were making decisions to give booster doses. And in my view, if you've got a limited supply and a zero-sum game, it's far more important to save lives, to benefit from that 90% protection from severe disease than to make a small difference in symptomatic infections. So we've looked behind, we've looked back, we've looked at mistakes we've made, we've looked at technological advances, we've looked at some of the things we've underestimated. What are some of the lessons for the future? Well, first is pay attention to warning signs. We had in the world the first SARS epidemic, a coronavirus going through civets. We had a second coronavirus epidemic in MERS. And so we saw the warning signs. We just chose not to heed them. We chose not to prepare for another coronavirus epidemic, partly because those didn't spread that much. And so we didn't anticipate that it would pose this kind of risk. The second lesson is you've got to be looking for new viruses. You've got to be looking for new variants. You've got to be looking in order to deal with a pandemic, in order to deal with an epidemic. Early warning is critical. You've got to deal with it early. Once it has spread, it's very difficult to control. And so having a global integrated surveillance system is critically important. The third lesson is you need pandemic preparedness in every country. I led South Africa's pandemic preparedness for flu back in the 1990s. And we were all set. We even bought amantadine, put it in warehouses because we said, when the flu hits, we won't be able to get hold of amantadine because it'll be in short supply and all the wealthy countries will buy it. We anticipated this inequity problem. And of course, we waited and no flu pandemic. So we lost confidence and people lost confidence in us. Well, we've got to find that confidence again. And these two reports highlight the importance of pandemic preparedness. So you've got to have a plan. I mean, it took WHO a long time, right? It took them 16 months to make a plan for global vaccine strategy. And I was part of the committee that did this. And we now finally have a plan. Now it's a question of getting to implement this plan. So having a plan and preparing for a pandemic is really important. And we've seen country after country the importance of trustworthy leaders who are consistent role models. And we've seen that in the US, we've seen it in South Africa, the importance of the way our president in South Africa deals with this pandemic. And we've seen how leaders like Dominic Cummings undermine the UK's efforts against the coronavirus by breaking the lockdown rules himself. So we've got to be good role models, and we need our leaders to set that example. So let me go on to lesson 5, which is, what does the next 12 months look like? And I won't go into any great details. This is a separate talk. For the benefit here, I've just provided you with a best case scenario. Let's say the virus gets no worse than the Delta variant. So the Delta variant is the worst it can be. And so we don't see any new major variants of concern. And we know that our current vaccines are effective against Delta, not when the immunity is waning, but certainly they work against the Delta variant, and they are pretty effective in preventing hospitalization. And with widespread high vaccine coverage, we can probably get away with just giving homologous booster doses and getting back to as much of our normality, allowing for low endemic transmission. Whereas a worst case scenario is we continually see new variants, including an immune escape variant. And that's because we have patchy coverage, because that's when we have parts of this world that just don't have vaccine coverage that enables the virus to be controlled. And so what's going to happen? We need to make new vaccines, to give heterologous boosters. We're going to need ongoing public health measures to prevent repeated waves of infection. And then somewhere in between this best and worst case scenario is where perhaps the virus still has one or two more variants up its sleeve. And in the course of the widespread transmission we're seeing in much of Africa and other poor countries, in the presence of immunocompromised individuals, we may see yet a few more variants emerge, perhaps even a vaccine escape mutant. In fact, if a variant can't escape some level of vaccine immunity, it won't be able to take hold because such a high proportion of the world has been vaccinated already. And so we may see a few more waves of infection before the virus exhausts its ability to mutate without fitness, of course, in which case we're going to need heterologous boosters before we can get back to normal, where we will just allow a low level of endemic transmission to set in. So these are just some of the scenarios looking ahead. So let me end off with, it's very important for one pandemic to teach the next pandemic. And so let me provide a key lesson from HIV for COVID-19 in concluding that there's a fundamental thing we learned in HIV, and that's mutual interdependence. And we saw that, and I'd like to quote from UNAIDS, the AIDS movement demonstrates that with a shared vision, shared responsibility, and through global solidarity with the leadership of people living with HIV, affected communities, and individual action, we can change the course of history. And we have. We have taken a disease that was uniformly fatal to one that's now just a chronic manageable condition, even in the poorest of countries, through our global solidarity, through the Global Fund, through PEPFAR. And our efforts at trying to do that through COVAX just haven't succeeded. And so we've got to recognize our interdependence. And we've got to fight pandemics together. The COVID-19 pandemic, when it was first emerged, it needed global cooperation. It demanded global cooperation. Instead, countries chose a me first and self-interest, I guess somewhat justifiably because they were scared, they were concerned, they didn't know this virus. But little was done to protect the poorest or to distribute vaccines equitably. Global tensions, such as that between the US and China, were heightened. Wars and conflicts continued raging on. And the UN pleas for ceasefires simply went unheeded. And the WHO, which is our lead global agency to fight the pandemic, became a political battleground between the US and China, with the US even withdrawing from the WHO. So when humanity needed to create a united front against a global threat, just think about it, what if aliens from outer space came in and posed a global threat? Are we going to behave like the way we did against COVID-19? Because we failed. And we simply cannot afford to fail again. We must succeed in the next pandemic for the sake of humanity. But I can't say it any better than Pope Francis. So let me quote from Pope Francis in an op-ed that he published in the New York Times. And I'd like to quote him. The pandemic has exposed the paradox that while we are more connected, we are also more divided. To come out of this crisis better, we have to recover the knowledge that as a people, we have a shared destination. The pandemic has reminded us that no one is saved alone. What ties us to one another is what we commonly call solidarity. Solidarity is more than acts of generosity, important as they are. It is the call to embrace the reality that we are bound by the bonds of reciprocity. That reciprocity is, I am safe when you are safe. You are safe when we are all safe. One country is safe when all countries are safe. And he ends off with, on this solid foundation, we can build a better, different human future. Thank you very much.
Salim, thank you very much for this presentation. There are lots of questions. You addressed many of them at the very end of your talk, but I'd like to go back to the 5 major global impacts you described. They're characteristic of past global pandemics, such as the 1918 pandemic influenza. And here we are a century later with COVID-19 suffering these same impacts. So we're at an educational institution, and there's curiosity. How can we better educate people about the issues you raise? For example, you ended with reciprocity, the social cost, for example, of vaccine inequity. How do we educate people?
I think the first thing that we have to do is that we have to get our leaders to be accountable. Because when our leaders are accountable, they understand that they have a responsibility to their own citizens, but then they also come to terms with the fact that they have a responsibility that goes well beyond their borders. And we see that in economics. We see that with the G7. We see that with the G20. The G7 understands that their economies are fundamentally interdependent and that they make joint decisions, and they stand together in the G20. In this case, our leaders needed to come together under the rubric of the United Nations. They needed to see that this was a problem that went beyond individual countries or individual regions. And the inequity I referred to, I have to say, I've just referred to it as inter-country, but those inequities are just as severe within countries. That if you look at the vaccine inequity between those parts of the country where you got high vaccine coverage, or when you look at whites compared to blacks, all of those inequities are still there. So I think every one of us as individuals have to keep our politicians and our leaders, not just our politicians, but our leaders in all civil society, in business, in government, accountable. And that accountability is about protecting all of mankind. And that, I feel, is one of the important things going forward. It's very hard to do in some countries, but one that without which I see very little hope.
You showed 3 possible scenarios for the next 12 months. Which do you think is most likely at this point, and why?
So I've had this debate with several of my colleagues. So some, like, Eric Topol, believe that, he's not, I don't think he's believed, but he's argued that probably it's going to be hard to get a variant that's worse than Delta. And there are others who also have made that argument. I have a slightly different perspective because I come from a setting where we have had Beta, and Beta is far worse than Delta when it comes to immune escape. Beta's 3 key RBD mutations all confer immune escape in different ways. So Beta is a far more dangerous, potentially, in a vaccine, in a vaccinated population. I mean, you saw that beta cares little for AstraZeneca vaccine, right? So if you've got a country with high levels of AstraZeneca vaccine coverage and you introduce beta, it will run through that population, and beta causes quite severe waves. So I think as much as we are tired, we are fed up, and we are done with this virus. We want to banish it from our thoughts. I think this virus is not done with us. I think this virus has somewhere up its sleeve. Yeah, it's got a variant or two that's still going to come out there. And I think that that's what will happen in all likelihood before the virus settles down and gets to a point where, it's really not going to change much, because the other 4 coronaviruses have all reached that point. They've all reached the point where, they're quite stable. They get the minor mutations, but they're quite stable, and we don't really care much about the other 4. And I think we'll probably see this one going in a similar direction. They'll probably might not be as harmless as the other 4, but it'll also become an endemic virus.
Do you think it'd be useful at this point to declare an end to the pandemic and just deal with an endemic virus?
So I think that Israel was a lesson in that regard. Israel reached very high coverage very quickly, and then went immediately to releasing many of its restrictions. It did so quite fast, actually. And of course, their 4th wave came with a vengeance with the Delta variant. So they learned the hazards of releasing all your restrictions. So I think that while we should release some restrictions, because vaccines do provide protection and vaccines do reduce viral load and transmissibility and asymptomatic infections, that we can afford to ease a lot of restrictions, especially in the outdoors. But I don't think we can release most of our restrictions indoors. So I think when it comes to indoor situations, the risk is still too high, particularly if a new variant emerges and is now going to spread. It would do so quite quickly if we didn't have restrictions indoors. So I can see that we would need to maintain some indoor restrictions before we can get to a point where we would say, okay, we can release all our restrictions.
Salim, I think we all benefit by having people like you so focused on the issues you raise. And I want to thank you again for presenting to us.
It's an absolute pleasure. Thank you very much. Lovely to see you all.